Assalamu alaikum students, welcome to another lecture of chapter Chemical Thermodynamics. Before starting the chapter, let's recall what we have done till now. In the previous lectures we have discussed what is meant by thermodynamics, what are the scopes and limitation of chemical thermodynamics, what is the basic concept of chemical thermodynamics that included types of system, types of properties, that is extensive or intensive properties, state of the system, state variables, state function, path function, and nature of heat and work and different types of thermodynamic processes. These many topics we have already covered. Today we are going to start with the topic expression for pressure volume work. Now what is mean by pressure volume work? Look, I have already told you all that in thermodynamics we will speak about the work that will be related to the expansion or compression of a system. Okay, so what is pressure volume type of work? It is very simple. It is the work that is done due to the expansion or compression of a gaseous system against an external opposing pressure. Okay, it means there is a gaseous system which is either expanding or compressing against an external opposing pressure. Remember, I am using the word against an external opposing pressure. Okay, so this is known as what? Pressure volume type of work. Now, how much work is obtained when the gas undergoes expansion or compression, that can be determined with the help of an expression. Now let us derive that expression, which will tell us that how much work is done when the gas undergo expansion or compression. For finding it out, let's assume a gaseous system. Okay, let's say that we have a cylinder. Okay, in this cylinder a gas is enclosed and it is fitted with a piston. A piston is a special lid. Okay, this special lid is supposed to be rigid, movable and frictionless. It means that it can easily go up and down without having any friction with the wall of that cylinder, because if there is friction there will be loss of energy. Okay, so what we are assuming that this piston is frictionless. Okay, it does not have any friction with the wall of the cylinder and it is rigid. Okay, and it is easily movable. Okay, so let's say that we have a gaseous system enclosed in a cylinder fitted with a weightless, rigid, movable and frictionless piston. Okay, let's say that the volume of the gas is V1 and the pressure of the gas is P. The external pressure that is acting on that piston is denoted as Px. Okay, now this is our initial state of the system. Now let's say that the system is undergoing expansion. Whenever the system expands, its volume will increase. Okay, so let's say that the volume of the system increases, and as it increases it pushes the piston up against the constant external pressure. Okay, so the piston is moving against the pressure. Okay, and it will occupy some new position. Okay, this is a new position of the piston. Because of the expansion, the volume has increased and the piston has moved up and traveled a distance d to reach the new volume V2. Okay, so let's say that this much is the distance traveled by the piston from V1 to V2 against the constant external pressure P external. Okay, this is happening. Now, as the system has undergone expansion, it means a work has been done. So let's see how we can determine with the help of this assumption what is the expression for work. Now what is work? work, according to the definition, we know that work is the product of force and displacement. That is, it is the displacement of an object in the direction of application of force that I have already explained. Okay. So by the definition of work, we know that W equals to F into D, where F is the force and D is the distance traveled. Okay. Now here what is happening? What is the force which is acting in this system, and what is the distance that is traveled by the system? So you can see that the piston has traveled the distance from V1 to V2. So this is the D, that is distance traveled by a piston. And what is the force that is acting here? The force which is acting here is the external pressure. But this external pressure is acting against the direction of the movement. The piston is moving up and the external pressure is pushing it down. So we will say that the force acting here is nothing but the external pressure acting on the area of the piston A. Let's say that this area, circular area of the piston, is denoted by A. And what is the force that is acting here? The force which is acting here is nothing but the external pressure that is acting on the area of surface of the piston. But as the direction is opposite, we will substitute a negative sign before the pressure, which indicates that the pressure is in the opposite direction of the movement of the object. Okay. So this is your expression of W according to the definition of work, and this is your equation for force according to this scenario. Now let's substitute this equation into the above equation. When you will substitute it into the above equation, you will get W equals to minus P external into A into B. Okay. We have substituted in place of force its value. Okay. Now what is this A multiplied by D? This A is the area of surface of piston and D is the distance travelled by the piston. When you multiply this area with the distance travelled, you will get what? The volume that has been increased. Okay. You will find that this is the volume which is increased due to the movement of the piston from V1 to V2. So you are finding how much change in volume is happening when you multiply A with D. So A into D can be replaced by what? By delta V. I can write here delta V. The multiplication product of A and D will give us what? The change in volume, that is delta V, that has taken place. Okay. Now how I can find out delta V? It is very simple. If I subtract V1 from V2, I will get that how much volume has changed, that is delta V. So I can again rewrite this equation like this, that is minus P external into V2 minus V1. Okay. So this is your expression for pressure volume type of work. The expression was very simple. We have assumed what? We have assumed that we have taken a gaseous system enclosed in a cylinder that was fitted with a piston. Okay. The area of the piston was A, the pressure of the gas inside is P, and the initial volume of the gas was V1. When the system undergoes expansion, the volume of the gas will increase from V1 to V2 and the piston will move upwards against the external opposing pressure. Okay. When the system moves to piston moves upward, it reaches certain value V2 and the piston travels a distance which we say is equal to D. assumptions we have made. Now from the definition of work, we know that work is the product of force into displacement. Now what is the force that is acting in this case? In here we observe that the force that is acting here is nothing but the external pressure acting on the area of the piston. Okay, but since this force is acting against the direction of movement of the piston, we have added a negative sign indicating the force is opposing pressure. Okay, so force can be written as minus px into A, that is area of the surface of piston. Then we have substituted this equation into the equation of work. We got what? W equals to minus P external into A into D. Now this A multiplied by D is nothing but the area of surface of piston multiplied by the distance travelled by the piston. When you multiply these two, you will get what? The change in volume, that is the increase in volume that has taken place due to expansion. So in place of A and D, we can substitute delta V, that is change in volume. Okay, and when you substitute this, you get your equation of work, pressure volume type of work, which is W equals to minus P external into delta V. What is delta V? It is final volume minus initial volume. Okay. Now in this, the case we have discussed for deriving the expression was the expansion of the gaseous system. Okay. So what happens here, when you get some value for the external pressure and V2 and V1, the work done you will obtain here, the value of work you will obtain here would be negative or positive. We can directly find it out here. You can see here that the V2, the value of V2 is greater than the value of V1. It means you are subtracting a lower value from a larger value. Obviously, the answer you are getting delta V is some positive answer. Okay. Now this answer is then multiplied by the pressure. Pressure, can we have the pressure negative value for pressure? No. Pressure has to have some value. Okay. It can never be negative. Okay. So you multiply your delta V with the pressure. But before that, we have the negative sign in the equation. This negative sign does not mean that the pressure is having negative value. No. The negative sign means here what? That the pressure is in opposite direction of the movement of the piston. Okay. That is why what? The pressure is opposing pressure. That's why the negative sign is put here into the equation. Okay. Now when you multiply the value of pressure with delta V, you are going to get an answer. Whatever answer, before that you will have the negative sign. Okay. It means the W you are getting is negative, which indicates what? That the work is done by the system. It means whenever expansion is taking place, the system does the work. And in doing the work, the system loses energy into the surrounding. So this negative indicates that there is loss of energy by the system into the surrounding. That is, work is done by the system. Okay. So whenever expansion takes place, you always remember that the work will come as negative, which means that work is done by the system and there is loss of energy by the system. Okay. Now let's see that if we had a work of compression instead of expansion, let's say compression is taking place. So when compression happens, what happens? The piston is going to move down. Okay. There will be decrease in volume. The piston will move down and you will have V2 whose value will be less than your V1. Okay. Now piston is moving down. Okay. V2 is less than V1. Now I would say that when the compression happens, what happens here? The V2 is less than V1. It means that you are subtracting a larger value V1 from the lower value V2. You are going to get the answer of delta V some negative value. Okay? When you substitute this delta V in here in this equation, it means you are multiplying P external, which has the negative sign with it, with an answer which is also negative. So this negative and this negative will become positive, and you will get the work which is having a positive value. Okay? It means that whenever compression happens, the work is done by the surrounding on the system, and the system gets compressed. And this positive work indicates what? Gain in energy of the system. So whenever compression happens, the system gains the energy. There will be increase in energy equivalent to the amount of work done on the system. Okay? So compression means answer will be positive, means what? The work is done on the system and there is gain of energy. Okay? I hope you have understood what is meant by pressure volume type of work and how we have determined the equation of pressure and volume. Okay? By taking into consideration the expansion. Okay? So when a gas expands, we have to assume we have to take some things in assumption. You will take the help of this diagram and you will describe how you are determining this thing. Free expansion is a very simple topic. It is what? The expansion of a gaseous system against zero opposing force. Means a gas is undergoing expansion, but there is no opposing force acting on that expansion. So let's find out what would be the work done when the free expansion takes place. We know the expression of work is W equals to minus P external delta V. We know here as the expansion happens, we are going to get some value for delta V. But what is the value of P external here? There is no opposing force, means there is no external pressure. It means that value of P is 0. When we multiply 0 with anything, it means that the answer would be 0. So whenever free expansion takes place, the work done will always be 0. Okay? This was free expansion. Another important type of work which we will discuss is maximum work, known as or denoted as Wmax. Now before finding out the expression for Wmax, let us first understand the concept behind the maximum work. Look, we have seen what is pressure volume type of work and what is the work in case of free expansion. This is another kind of work which is known as maximum work. Now what is maximum work? The amount of work is maximum here. From the name we can guess here that the amount of work which we will obtain is going to be maximum. Now on what things the amount of work will depend. Here I have written a point there. Whenever any change is taking place, that is in a process, the amount of work done depends on the magnitude of opposing force. We know that W equals to P delta V, or you can say W equals to F into D, that is force. If you increase the magnitude of force, you are going to get the greater value or product of that for the W. Okay. So I am saying here is what? That if the magnitude of opposing force is maximum, you will get what? The maximum work from the system. Now what are the type of process where we can observe the maximum opposing force? So if you try to recall, you will come to know that we have discussed the reversible process, where we have defined that the processes which occur in such a manner that during every step of the process the driving force is only infinitesimally greater than the opposing force, and that can be reversed at any time to reverse the process. It means that during the reversible process, the driving and opposing force differs from each other by a very small magnitude, very small value. Okay, here you can say that you have opposing force at its maximum strength. It means you can obtain this kind of work Wmax only if your process is reversible in nature, because only in reversible processes the driving force is only little bit stronger than the opposing force. It means the opposing force is only little bit weaker than the driving force. It means it has its maximum value. So maximum work is obtainable only if the process we are observing is reversible in nature, because in reversible processes the opposing force has their maximum value. Okay, I hope you have understood it. And we have also discussed certain features of the reversible processes, that these processes are quite slow and takes place in infinitesimal number of small steps, and during each small step an equilibrium is attained between the system and the surrounding. Okay, so let's say for finding the equation also, let us assume a system. Okay, for deriving the expression of Wmax, let us assume that we have n mole of an ideal gas enclosed in a container that is fitted with a piston. Okay, let's say the initial volume of the ideal gas is V1, the pressure of the gas is P, and the pressure that is acting on the piston is P external. Okay, now let's say that this gas expands in isothermally and reversibly. Isothermally means what? The temperature remains constant. We are assuming that the temperature is constant throughout. And this gas undergoes expansion in reversible manner. It means the process can be reversed any time by the slight increase in the opposing force. Why we are assuming this? Because we want to obtain the expression for maximum work, which is possible only if the opposing force has the maximum value which is there in the reversible process. Okay, so let us assume that n moles of an ideal gas expands isothermally and reversibly. This is an important point to mention, that the gas expands isothermally and reversibly. Okay, from the initial volume V1 to the new volume V2. Okay, now for understanding it, we are saying that these processes are very slow. So let's say that suppose you had this system, on the piston you are pouring one fistful of sugar grains, sugar crystals. Now if you remove the sugar crystals, all the sugar crystals which we have poured on the piston, at once there will be sudden decrease in the pressure and the volume will suddenly increase. But what we are saying the process is reversible and very slow. So what you assume that, suppose you had this piston, and on that piston you have hundreds of grains of the sugar, and at every time you are removing one crystal of the sugar from the piston. Once you remove one crystal of the sugar, there will be very small decrease in pressure, external pressure. When the external pressure decreases, the equilibrium between internal and external pressure will get disturbed. Okay, and the piston will slightly move upward, so that the internal and external pressure can again be equal, that is, then equilibrium can again be achieved. In the same way, every time you are removing one crystal away from the piston, and every time there will be slight decrease in the external pressure, and the mechanical equilibrium of the system will get disturbed. To attain the equilibrium, the piston will move up by increasing the inner volume. Okay, so there will be small increase in volume for each small decrease in external pressure. Okay, so this is how the reversible process takes place, that every time a small change takes place, a small amount of work is done and a small change in volume will occur. Okay, so let us assume that during this process of expansion of a gas from V1 to V2, the process does not take place suddenly, but it takes place in infinitesimal number of small steps. During each small step, there will be small amount of work done for changing in volume, for bringing the change in volume dV against the external pressure Px. Okay, so let's say that the amount of work done for the small change in volume dV can be given by equation this. Okay, now why this is happening, why this change is taking place? Due to the decrease in external pressure, or due to the change in the internal or external pressure. Whenever this pressure equilibrium get disturbed, there will be movement in the piston and the volume will increase or decrease. So let's say that the change in pressure is given as dP, because there is small change in pressure, that's why I am using D. Okay, dP is P minus P external. So we'll say that P external can be equals to P minus dP. Now let's use this value of P external into equation 1. Now your equation 1 become dW equals to minus P minus dP into dV. This use of this small d indicates what? The small changes. Okay. Now open the bracket, it will become dW equals to minus PdV minus plus dP into dV. Since dP is very small and dV is also very small, their product will be small, even more smaller. Okay, suppose you are multiplying 0.1 with 0.1, it becomes 0.01. Okay, so when you multiply the two smaller values, the product is more smaller in value. So their product will be negligible. The value of these will be negligible. So we can neglect this. Okay, so let's say that since the dP and dV are very small, they can be neglected, and you can say that dW equals to minus PdV. Okay, why we have neglected it? Because the product of dP and dV is very small and can be neglected. Now this is the amount of work done when the small change in volume takes place. To find out how much work is done when the gas expands from V1 to V2, we can do the integration of it between the initial and final limits. So let's say that this is the initial state of the system and this is the final state, and let's integrate the work from initial to final volume, and integration will be done here also from V1 to V2. Okay, PdV. Okay, now we have assumed that the gas enclosed was an ideal gas. For an ideal gas, we know that for an ideal gas, the equation we know is what? PV equals to nRT. Now let's substitute this in the above equation. Now here change it, P equals to nRT upon V. Now let us substitute the value of P into the above equation. When we substitute it into the above equation, it will become what? Your dW will become W max equals to minus from V1 to V2 n RT upon V into D1. Now what is n here? N is the number of moles of gas, R is universal gas constant and T is temperature. Now since our system is a closed system, so number of moles of gas will not change. Okay, so n remains constant throughout the process. R is a gas constant, T is what? Temperature. A process is isothermal process, means the temperature also remains constant. So this whole term nRT is taken out from the integration because all are constants. Now in the integration we are left with what? dV upon V. Okay. So when we have this, what will be the next step? Minus nRT ln V from lower to upper limit. Ln is your natural log. That is minus nRT ln V2 minus ln V1. Okay. You can also write it as minus nRT ln V2 upon V1. Upper limit minus lower limit will give you what? ln V2 upon V1. Now ln is your natural log. Let's convert it to the log to the base 10. When we convert it to the log to the base 10, you will multiply it with 2.303 and RT log to the base 10 V2 upon V1. This is your expression of W max. Okay. So all the steps which I have mentioned here are important while deriving the equation of W max. Okay. Now we know that for an ideal gas, according to Boyle's law, P1 V1 is equal to P2 V2. This is according to Boyle's law. Okay. So I can say that P1 upon P2 is equal to P2 upon V1. Okay, we can write it. So from this you can modify your equation of W max and you can also represent it in terms of pressure of the gas as W max equals to minus 2.303 nRT log to the base 10 P1 upon P2. So these are the two forms of equation of maximum work. One is in the form of volume and one is in the form of pressure. Okay. I hope you all have understood what is W max. W max is the work obtained in isothermal reversible process. For finding it out, you have to make certain assumptions which I have explained, and then you will first find out the work for a small change in volume of the system and then do the integration of that small change to find out the W max. I hope you have understood till here. So today let's finish our lecture here. Inshallah we will meet in the next lecture. Until then, please be safe. Take good care of yourself. Allah Hafiz.